Venus, often called Earth's sister planet, captures the imagination of many. This nickname arises from the similar size and composition of Venus and Earth. Both planets are rocky and share similar density, yet the resemblance ends there. Venus is shrouded in mystery, with conditions so extreme that they challenge our understanding. The planet is covered by thick clouds of sulfuric acid, obscuring our view of its surface. Venus is the second planet from the Sun and orbits it every 225 Earth days. It is the brightest natural object in the night sky after the Moon. This dazzling appearance has fascinated humans for centuries. However, beneath this beauty lies a world of extremes. By unraveling its mysteries, we hope to learn not just about Venus, but also about planetary evolution and the potential for life elsewhere in the universe. The atmosphere of Venus is one of its most striking features. It is composed mainly of carbon dioxide with clouds of sulfuric acid. This dense atmosphere traps heat in a runaway greenhouse effect. As a result, Venus is the hottest planet in our solar system, even hotter than Mercury. Winds reach speeds of up to 224 miles per hour, faster than any storm on Earth. These winds circulate the planet every 4 to 5 Earth days. Rain on Venus is not like rain on Earth. Instead of water, it rains sulfuric acid. Lightning is another common phenomenon, sparking across the thick clouds. Despite its hostile environment, the atmosphere of Venus offers clues about the planet's past. Studying Venus's atmosphere helps us understand the potential future of our own planet if climate change were to spiral out of control. Beneath its dense clouds, Venus's surface is a landscape of volcanic activity. The planet is dotted with thousands of volcanoes, some of which are still active. These volcanoes range in size from small domes to massive shield volcanoes similar to those in Hawaii. The surface is also covered in vast lava plains, evidence of extensive volcanic eruptions in the past. Mountains and highland regions add to the diverse topography of Venus. Maxwell Montes is the highest mountain on Venus, reaching about 36,000 feet, higher than Mount Everest. The highlands are also home to numerous craters formed by meteorite impacts. The surface of Venus has been mapped using radar by missions such as NASA's Magellan spacecraft. These radar images reveal intricate details of the planet's geology. By studying Venus, we gain insights into the geological processes that shape rocky planets, including Earth. Venus is notorious for its scorching heat, with surface temperatures exceeding 900 degrees Fahrenheit. This extreme heat is primarily due to the runaway greenhouse effect. The planet's thick atmosphere is rich in carbon dioxide, a potent greenhouse gas. This gas traps heat from the sun, preventing it from escaping back into space. The greenhouse effect on Venus is much more intense than on Earth. The heat on Venus is so intense that it can melt lead and zinc. This extreme temperature is uniform across the planet, both day and night. The thick cloud cover ensures that little variation occurs between the equator and the poles. Studying the heat of Venus offers warnings for Earth. Understanding the dynamics of Venus's greenhouse effect can provide valuable insights into climate science and help us mitigate the impact of global warming on Earth. Section 5. Venus compared to Earth and other planets. Venus is often compared to Earth due to their similar sizes and compositions. Both planets are rocky and have similar densities, suggesting they formed under comparable conditions. However, the similarities largely end there. Compared to Earth, Venus has a much thicker atmosphere composed mostly of carbon dioxide. This dense atmosphere creates extreme surface conditions, unlike the more temperate climate of Earth. In contrast, Mars, another rocky planet, has a thin atmosphere primarily composed of carbon dioxide, leading to cold and dry conditions. Venus and Mercury, the innermost planets of the solar system, also present interesting contrasts. Mercury lacks a significant atmosphere, resulting in extreme temperature fluctuations between day and night. The study of Venus, Earth, and Mars, the terrestrial planets, helps scientists understand the diversity of planetary environments. Section 6. Fascinating facts about Venus. Venus has many intriguing features that set it apart from other planets. One of the most interesting is its rotation. Venus rotates on its axis very slowly, taking about 243 Earth days to complete one rotation. This means a day on Venus is longer than a year on Venus, which lasts about 225 Earth days. Additionally, Venus rotates in the opposite direction to most planets, including Earth. This retrograde rotation means the Sun rises in the west and sets in the east. Venus has been a target for exploration for many decades. The Soviet Union's Venera program achieved several firsts, including the first spacecraft to land on Venus and transmit data back to Earth. Despite its hostile conditions, Venus continues to be a subject of fascination and study. Section 7. Missions to Venus. The exploration of Venus has a rich history marked by numerous missions. The Soviet Union's Venera program led the way, with Venera 7 becoming the first spacecraft to successfully land on Venus and transmit data back to Earth in 1970. Venera 9 sent the first images of the Venusian surface in 1975, revealing a rocky and desolate landscape. NASA's Magellan mission, launched in 1989, provided detailed radar mapping of Venus. This mission used synthetic aperture radar to penetrate the thick clouds and map 98% of the planet's surface. The data revealed extensive volcanic plains, mountain ranges, and evidence of tectonic activity. More recently, the European Space Agency's Venus Express mission, which operated from 2006 to 2014, studied the planet's atmosphere and weather patterns. Future missions to Venus are planned by NASA and other space agencies. These missions hold the promise of uncovering new insights about Venus, contributing to our broader understanding of planetary science and the conditions that can lead to habitability. Section 8. The mystique of Venus's rotation. One of the most puzzling aspects of Venus is its unusual rotation. Unlike most planets in the solar system, Venus rotates retrograde, meaning it spins in the opposite direction. This means that on Venus, the Sun rises in the west and sets in the east. The reason for this unusual rotation is still a topic of research and debate among scientists. Venus's rotation is incredibly slow. It takes about 243 Earth days to complete one rotation, making a day on Venus longer than a Venusian year. This slow rotation is thought to be influenced by the planet's dense atmosphere and gravitational interactions with the Sun. Understanding the rotation of Venus is important for planetary science. The study of Venus's rotation also helps scientists understand the complex interactions between a planet's atmosphere and its rotational dynamics. Section 9. Venus's visibility from Earth. Venus is one of the most easily visible planets from Earth. Its brightness and proximity make it a prominent feature in our sky. Venus is often seen just before sunrise or just after sunset, earning it the nicknames Morning Star and Evening Star. This visibility has made Venus a significant object of observation throughout human history. The planet's brightness is due to its thick clouds, which reflect a large amount of sunlight. Venus can reach an apparent magnitude of -4.6, making it the brightest object in the sky after the Sun and Moon. Observers can often spot Venus with the naked eye, and it is a popular target for amateur astronomers using telescopes. Venus undergoes phases similar to the Moon, ranging from a fully illuminated disk to a thin crescent. For many, observing Venus serves as an introduction to the wonders of astronomy and the dynamic nature of our celestial neighborhood. Section 10. The importance of studying Venus. Studying Venus is crucial for several reasons. It provides insights into the processes that shape planetary environments. By understanding Venus, scientists can draw comparisons with Earth and other planets, offering broader perspectives on planetary science. The extreme conditions on Venus serve as a natural laboratory for studying the effects of greenhouse gases and climate dynamics. Venus also helps scientists explore the potential for habitability in our solar system and beyond. While Venus is currently inhospitable, studying its past may reveal whether it once had conditions suitable for life. This knowledge can inform the search for habitable exoplanets orbiting other stars. Additionally, Venus serves as a cautionary tale for Earth. By continuing to study Venus, we uncover the mysteries of our solar system and gain insights that are crucial for the future of planetary science and the preservation of our own planet.